Okay, so here's today's board work problem. So take a look, graph y equals 1/5 x minus 3 by brute force, which means plotting points, and also by using the slope and intercept. So graph this two ways. If you're not sure about one of them, just graph the way that you do know. But see if you can do it both ways. And um, pause the video, then work on it, and then start the video back up. Okay, so we are back. So what do I mean by brute force? Plotting points. If you aren't familiar with the idea of graphing by plotting points, um, take a look. So this just means we're going to make a table of x and y and plot some points. We'll pick some values of x and we will simply calculate y. What y is for each of those values of x, and that gives us an ordered pair. So every time we put in a value for x and calculate y, that gives us an x and a y, which is an ordered pair, and we can graph that. And we just need to graph enough of those to get an idea what the graph looks like, and then you just fill it in. So think about how many we need to use for this one. How many points do we need to have that idea, to have an exact really idea of what it looks like? So, well, let's just plot some. We can pick anything we want for x. So let's pick 0. And that just means we put in 0 for x. You can probably do this in your head, but I'm going to write it down over here anyway. Y equals 1/5, and we're putting in 0 for x, minus 3. So 1/5 times 0 is 0. Minus 3 is negative 3. So when x is 0, y is negative 3. So what else would we want to put in there? Well, let's just put another simple number. Let's put in 1. 1/5 times 1 minus 3 equals. Okay, this time it's a little more involved. 1/5 times 1 is 1/5. Okay, and that's minus 3. And so that's 1/5 minus 3. So when you use this brute force method, you have to be willing to put up with some fractions. We'll talk about ways to avoid that, but it's okay to have fractions. Um, and it's okay to just calculate this on the calculator. We could do it either way. We could get a common denominator and subtract, but I'm just going to do it on the calculator. So 1 divided by 5 is 0.2, and then 0.2 minus 3 equals negative 2.8. And next time maybe I'll have a calculator on the screen so you can watch the keystrokes. So we got negative 2.8. Okay, just punching it in the calculator. So that's our next point. When we put in a 1 for x, which we did right here, okay, we put that in, we get negative 2.8. So put in a 1, you get negative 2.8. We have 2 points, and I'm going to go ahead and do another one. You might think, well, we only need 2, and if you're thinking that, you're right. This is a line, so we only need two points. But I want to show you a consideration. When you're using this brute force method, it makes sense to try to get simple results that don't involve fractions. So what could we put in for x so we don't end up with a fraction at all? And hopefully you realize, well, if x was 5, then 1/5 times 5 would be 1. So let's put in 5. And let's make sure it comes out like that. 1/5. We're putting in 5 for x minus 3, and sure, 1/5 times 5 is 1 minus 3 equals -2. Okay, so that gives us 3 points. So we plot those. 0, -3 is right here. Actually, let's put that in a different color. Let's make that blue. So, oh, wrong place. 0, -3 was our first point, right? Okay. And our second point right here, when x is 1, y is -2.8. So that's the ordered pair 1, -2.8. So here's 1. -2.8 is almost down to -3, but not quite. And then we have 5, -2. Whoops. So 1, 2, 3, 4, 5, -2. Like about right there. And you can see, I can tell my second point isn't quite low enough. But anyway, they're pretty close on a line. And so there's the line. Now, it's important to realize this brute force method can be used to graph any function, any equation. With a line, it's simple because we only need 2 points. With a lot of equations, you may need more because you need enough points to show the shape of that, such as in the absolute value equations. You have to get that V shape. If you have points that are only on one side of the V, you won't be able to actually get the equation graphed. But for lines, it's pretty simple. 2 points is enough. Okay, so now let's go ahead and do it the other way, the easy way actually, by using slope and intercept. This one is in slope-intercept form. So it's pretty easy. We don't have to put it in slope-intercept form. It already is in slope-intercept form. So that's actually going to be easier than the way that we just did it. The intercept is -3, and of course that is the same point. Okay, we already had. The slope is 1/5. Okay, the slope is right there. So the rise over the run equals 1/5. So we just go from where we are. That is our first point, right? We got from the intercept. We go up 1 and over 5. 1, 2, 3, 4, 5. And it actually turns out to be a point that we already used. It didn't have to turn out that way. It just did. So the point we got from using the intercept and the point we got by going from that intercept to one more point using the slope ended up being the point we'd used before. Let's go ahead and get another point using this rise over run. We could also write rise over run as -1 over -5, right? That would still come out to a slope of 1/5. -1 over -5 is also 1/5. And if we do that, we go starting at our intercept, we go down 1, okay, and then to the left 5. 1, 2, well, let's see, 1, 2, 3, 4, 5. right there, and down 1 and to the left 5 is right there. So it came out pretty good. 1, 2, 3, 4. It's more like here. Yeah. Okay. So that's another point we can get just by using the intercept as a starting point and then the slope to get one more. So that is quicker and easier than the brute force method. And generally, if you know something about the type of equation you have, there is an easier way than the brute force method. For absolute value equations, remember, if we can find that vertex, we can just graph it using our knowledge of the vertex, and then using our knowledge of the absolute value equation, we can graph that pretty quickly. It's faster generally to use the special knowledge that you have about the type of equation that it is. But good old tried and true brute force method. Okay, if you can't remember how to do it for this certain specific type of equation, maybe you can't remember what to do with slope and intercept, you're just kind of stuck, pull out the old brute force method. And we will be using it later in this year, graphing other types of equations and functions. So just stay tuned. But I wanted to give this example. We haven't used the brute force method a whole lot in class, so I thought I would do it here on the board work.